All right, folks, we're going to go ahead and get started. We got a lot to cover today. First off, I am Kevin Olivieri, and I will be moderating this event. Thank you so much for joining. This is the first Agentic in Action event that we've done. This series is going to be about real AI deployments, not demos, and what it actually takes to get these systems into production. Today, we're focused on government and regulated industries where, trust, reliability, and accountability are absolutely mission critical. We're going to talk about what breaks when teams move from experimentation to deployment and what leaders need to do and see before they can trust these systems operationally. I want to give the panelists a moment to give a quick introduction each. So we will start with John, then Mike, and finally, Chris. John, the floor is yours.
Yeah, I'm John Hickey. I'm the president of Schell. We're a cybersecurity company focused on the federal market. Prior to joining Schell, I was the cyber executive at DISA as well as the risk executive prior to that. And then I spent 27 years in the Army operating, deploying, and developing networks and cyber capability.
Great. Mike?
Hi, everybody. Mike Baca. I'm the CIO of Schell. I work for John. I came out of the Marine Corps. I spent 16 years there. Varied background, early on human and counterintelligence, and then transitioned to technical counterintelligence, where I ended up leading a interagency training center, network, and wireless threat hunting training program. And at the moment, I also assist different federal customers in identifying solutions and really solving difficult problems. Thanks, everybody.
Great. And Chris?
Cool. Yeah. Thanks, Kevin. My name is Chris Sniffen. I'm the Federal Applied AI lead here at Snorkel AI. My background is also military originally. I spent 8 years in the Army before transitioning to the National Security Agency, where I got to do a whole bunch of different things, but ended up working in AI research before I left the agency and joined Snorkel. Now I get to spend my time building custom agents and benchmarks for enterprises, which is just a lot of fun.
Fantastic. Thank you all. So I guess let's kick it off right away. Chris, I got a question for you. Considering that most organizations aren't asking if they should use AI anymore, we've moved past that. They're really asking a different question, like why something worked in a demo and then 6 months later it's stalled out. What are you seeing?
Yeah, great question and all too common, right? The big difference in my mind between a demo capability and a production capability is trust, right? I need a demo to be useful, but I need a production tool to be reliable. Projects stall when teams can't demonstrate sustained reliability in critical workflows. And demonstrating reliable behavior comes down to system evaluation, not generalized accuracy metrics, because those usually just don't cut it. Adopting an AI system is it's a lot more like hiring an intern than buying traditional business software, if you will. If you're hiring an intern, you probably would not make that decision based on something like a GPA. The GPA tells you something, but it doesn't tell you whether the person can do the job or whether you can count on them to follow the right process, to use good judgment, and to know when to ask for help. That kind of complexity is closer to what we're asking AI agents to do now. We're asking them to work inside messy business processes, to read ambiguous documents, interpret policy, retrieve evidence, and use tools, or decide when something needs to be escalated. Those types of tasks don't have kind of calculator 2 + 2 = 4 determinism built in. There may be multiple reasonable outputs. The right answer might depend on context, and the cost of being wrong might vary a lot from one case to another. And that's where the pilots stall. The demo shows that the system can produce something useful, but production requires a different kind of evidence. Leaders need to know, where does the system work? Where does it fail? How do we know? And what happens when it's wrong? So the bottleneck is not getting an AI agent to work once, it's knowing when it's reliable enough for a real workflow. To build on that a little bit, not every AI use case carries the same trust burden. Off-the-shelf LLMs are already very useful in lower risk general purpose workflows. drafting, summarization, research assistance, and so forth. But as you move up and to the right in this chart that you're seeing, right, the trust problem changes. It changes when AI moves into specialized consequential workflows, underwriting, fraud review, clinical assessment, access authorization, cyber operations, procurement, things like that. In those settings, being generally capable is not enough. The system has to understand the organization's policies, data, terminology, risk tolerance, and so on. It has to know what evidence matters versus what evidence doesn't matter. It has to know when to make a recommendation and when to escalate. And the more consequential the workflow, the stronger the evidence has to be before leaders can trust it. So again, the issue is not that off-the-shelf LLMs are useless, they're very useful. But in the highest value workflows where we want to get out of demo and into production, you're going to be using specialized judgment. And that specialized judgment requires specialized evaluation grounded in evidence, not vibes, as we like to say.
I love that. I love the grounded in evidence, not vibes. So for leaders listening, what does that evidence actually look like?
Yeah, when I say evidence and not vibes, I mean trustworthy AI can't be a subjective impression that the answer looks good. For a system to be trusted in production, leaders need evidence at several different levels. They need it to be tested on examples that actually represent the workflow that they care about. They need evidence that the subject matter experts that usually are working in that workflow agree with the evaluation criteria that's being used. They need evidence that the process that the system followed, what it retrieved, what tools it used, and so forth, is actually being tested, all of those different process points. And they need evidence that failures are not just logged somewhere, but that they're actually being turned into improvements for the system. And that applies across industries, right? In financial services, it might be a payment hold or a fraud escalation. In insurance, it might be a claim rounded for special investigation. In healthcare, it might be a chart that's prioritized for review, or even something as consequential as, getting a refill on your prescription or something like that. But the common pattern is that AI output starts to affect the business or mission state. So at that point, the answer looks reasonable is not enough. You have to know what evidence actually supports it, how it was evaluated, and what the system does. And sorry, go ahead.
I was going to say one of the things that kind of I want to hit on is that essentially my old line of work, human, right? I would target humans to get into systems or environments that were extremely difficult to get into because maybe the technical, operational, and procedural controls that were in place prevented access for me. So we would target the humans, and it's actually still effective today because humans are always going to be the most vulnerable entity in any system, in any equation, in any security stack. It's always going to be the human. And one of the go-tos that I've seen is some customers might think that we could just throw and connect our data to an LLM and it's going to give me all this wonderful data that I can use and leverage. The problem is most of the LLMs are built for engagement, right? Essentially, the goal is to keep you on their model. So there is a play in your own confirmation bias. So whenever you get an output, sometimes it can be difficult for you to be objective as the human to say, this is a valid output, or maybe this is not a valid output. And without any way to measure that, it really becomes difficult because how do you put the genie back in the bottle?
Yeah. These are all great points, and I'd love to kind of take this opportunity to bring you into this, John, because in your environment, a bad decision around AI isn't it's not just embarrassing; it can have real operational consequences. And building off of that, what would you say has to be true before leaders can really trust AI generated decisions at scale?
Well, again, I like good vibes. Those are always good. And we got a lot of people that can, vibe code now. You brought the bar down. So, but you still have to make sure that you understand kind of what those pieces look like, right? And, I'll give you an example. Like, you got to be able, the big push is for zero trust, but the biggest challenge with zero trust is, do we have the data labeled where we can make those decisions? And is it complete? Is it consistent? And I would say, that's a hard one, because it's not, right. And I'm a perfect example of, like, I'll go back years ago when I was on the UCOM staff and I was supporting operations, classified data. I worked on SIPRNet most of the time, but our allied partners didn't, right. And when I had to make something happen, I'd make like a Mike Baca nervous. I'd have to figure out how to share information, right? And most of the time that information was overclassified. It's still the same problem today. So I think it's a matter of kind of how you get after that, and something like an AI capability that can help you overcome an impossible task of, yesterday, was, how am I going to label all this data? How am I going to get it right so I can make a solid decision? I think AI is going to enable that in real time, and I think that's required truly to have trust in some of the data sharing capability that's required to support military operations or support things in other areas of the federal government. So,
And
Yeah.
John, what gives you the trust in that system, right? In the classification, what makes you comfortable as, former commander, that the system is classifying it correctly and it's not, underclassifying or overclassifying? Same problem that, I was an individual that contributed to, just because I would always write a report secret, no foreign.
that's an intelligence officer that admitted they were wrong. I love it. Or right, depending on what you want to look at, because you still got to complete the operation. You got to take some risks to get it done, right? And that's sometimes what folks don't understand. Everybody critiques later, but the bottom line is that mission has to be accomplished. So you do it with the mechanisms you have.
In your experience, what would you say is the harder problem here? Is it the technical one, or is it getting the operators to trust the automation once it exists and it's out there and being used?
I think it's the trust, the information. There are technical challenges, but trust is still like, can I trust it? In an AI world, that's going to come down to, is there trust of
Mhm.
the system itself and the agents making the correct decisions. So,
Yeah. So, Chris, I'd love to kind of tie this back towards evaluation. A lot of teams will say, we tested the model, it scored well on benchmarks, we ran some examples internally. Why isn't that necessarily enough for the kinds of workflows that we're talking about here?
Yeah, good question. I think public benchmarks can be really useful, but I think they often answer a narrower question than leaders necessarily think. A generic benchmark can tell you how a model performs on a broad standardized set of tasks in a given domain. It doesn't tell you whether the system is ready for your workflow, though, or your data, the particularly policies, users, and tools that you have in your environment. And it certainly isn't calibrated to your error tolerance. There are three kind of common gaps there. One is that a general reasoning benchmark won't tell you whether an agent follows your claims policy. This is the specificity problem, maybe, of your particular environment. Second, it misses the process a lot of times. Most people are comparing aggregate statistics on a benchmark. So, it got 87% of terminal bench or something like that. And that doesn't really tell you anything about how the agent got to that score. So, an agent can get the right answer and completely base it off of the wrong evidence, for example. So that's the second point. And then the third point is that those benchmarks just get stale over time. So your workflow is always changing. The operating environment is dynamic. Threats change, data changes, and the benchmark has to keep up with those changes. And otherwise, the evidence is really kind of point in time evidence, and it doesn't keep up with the time. So I guess from my perspective, a benchmark score is useful, but it's not evidence that can be used to go from demo to production unless it reflects very accurately the workflow that you're using in your particular environment and considers the process in line.
Yeah. So everything that we've talked about so far assumes that, you have the luxury of getting it right before it ships. Mike, your world doesn't exactly work that way. Whether it's a threat actor moving faster than your detection, or if it's a business decision that simply can't wait for the model to be perfect, at some point you have to act on this incomplete information. How do you think about that threat landscape and separating a recommendation you can trust from one that gets you into trouble?
Ooh, it's a great question, Kevin. Okay, so kind of leaning into something that John mentioned before is that the mission still has to be accomplished, right? Military, the mission is combative. The mission could be protection of the network environment. It could be building a specific product, controlling the water, from if you're a water treatment plant. But really, you have to make a decision when it comes down to a point that maybe it's a threat actor knocking on the door, some sort of indication. And I mean, as cheesy as this sounds, the Marine Corps really beats into us that making a decision and executing that decision, I'll put it politely, effectively, um, is better than making no decision at all. Analysis paralysis is a phrase that is used commonly, and there's a reason why, right? If we don't make a decision and we don't perform an action based off that decision, there could be real world consequences, right? In a combat environment, that could be the execution of an attack or, assuming a defensive posture. Kind of rewinding back into my the days where as a human collector, there was a point where I was a young Marine and I had asked the base commander to shut down the base because I had an indication that there was potentially going to be an attack. And I will tell you, those that are in the military will understand this. As a young service member, asking that is a very, very difficult thing to do. And essentially you can't define what I was thinking on why I made that assessment. There were many different things that were involved in that, but I still made the decision to execute that. And as we kind of look forward into the way warfare is conducted today, and sorry, I'm using the combat, but I mean, the reality is that most of our network threats that we're facing as an organization where we might leverage some sort of AI system to protect it against is going to be generally a nation state level attack, because most of the solutions that are available today are pretty effective from maybe protecting against 90% of the the lower level attackers. But really, what that means is that also those lower level attackers that were lower level attackers yesterday are starting to leverage the tools of that LLMs and AI provides. So now they're quickly ramping up to speed to be almost as effective or as effective as some of these nation state level attackers. And so if you are, a small critical piece of critical infrastructure and you're protecting your network, your water treatment plant, and again, this is no knock on any sort of critical infrastructure teams because I've worked with many, and I will tell you, most of them are very, very talented, but they are overwhelmed, right? The resources are lacking many times for the protection of their environments, and so they have to make decisions, and they have to make those decisions based off of automated systems going forward. And again, we make decisions and they sometimes are incorrect. And back to the anecdotal example that I gave about shutting down a base, that decision was, my assessment was incorrect. But the reality is I didn't know if that decision was incorrect because did the attack not execute because the base was shut down, or did the attack not execute because it was never going to execute? So as kind of and kind of building back into that, right? And in what makes a decision, how do I make a decision as an operator? How do I trust that decision? How do I take a system that I'm using, say, to protect my network, and look at that and say, okay, I might find myself in a situation, if I'm protecting some sort of piece of critical infrastructure, I either shut down the network or I continue to run the network with the risk of this potential threat actor that may have gained access. And so I'm going to have to weigh that. And as I weigh that, I'm going to think about what are the implications of me shutting down the system, and do I really trust that security tool, that agent that identified that there's a threat actor in my environment? And kind of without that trust, right? It's difficult to make that decision. And so that the operator has to trust the system that they're using to make decisions, right? And again, if you don't trust it, you are not going to make a decision based on that system, and that agent is only going to disrupt your own kind of methodology and thought process. So again, it's, you have to have some way to identify, is this system accurate based off of what I need it or what I'm asking it to do.
Yeah. I'd love to dig in just a little bit more, like the cyber equivalent of that bad source report, where the system, it sounds confident, but the evidence or context underneath is weak. Could you expand a bit more in that?
Yeah, so one of the things that we do as humans, and again, it's hard to quantify this. And AI systems, agentic systems are really good at taking a defined process and producing a repeatable output. What they're not particularly great at this moment is taking in other factors that we as humans haven't been able to define yet, right? So I'll just give again back to that example. Why did I make the decision to request for that commander to shut down the base? Well, there were many different factors that were into play. It was the region that I was in, the characteristics, the mannerisms of that individual that I was speaking to. What tribe were they a part of? Yes, there were still tribes. There are still tribes in that region of the world. And what are the mannerisms of those individuals? What is their code of ethics for that particular group or that family? And so not being able to quantify that, but I could quantify it in my head, right? It was more qualitative than quantified. That's where kind of we have to have a way to build in some sort of metric to quantify what can be quantified, but also understand where there's qualitative assessments that need to occur.
Right. So, Chris, I'd love to bring you in here to think about practicality of the trust that we've been talking about in this agent world. When you're evaluating an agent, how do you define what good actually means? Like, what's changed that makes this such a challenge right now?
Yeah. Well, I mean, the complexity of the tasks has certainly changed. But I think maybe the best way to dive into that is just to talk about what good looks like, right? We have to stop talking about good as a generic property of a model, like the model is good enough or something like that. We need to talk about good for what? Good for what workflow, good for which user, good under what policy, good enough to advise a human, or good enough to make a decision or trigger an action. At Snorkel, we generally define good at 4 different levels: task, trace, outcome, and rubric. As you can see on the slide, we can just step through those. The task is what the AI is supposed to do, right? A vague task is going to create a vague evaluation. So good starts with the right level of specificity of task. The trace is how the system got there, what it retrieved, which tools it used, what evidence it relied on, what it ignored. So good means looking beyond the final answer and inspecting the whole decision path of the agent. The outcome is what changed in the workflow. Did the claim get routed? Did the ticket close? Did the document get labeled? Did the analyst receive a recommendation? Did an access decision change? So good in that case means measuring the outcome that actually matters. And the rubric, which is arguably the most important part of all of this, ties it together. It's how we judge whether the behavior as a whole was acceptable. Was it complete? Was it grounded? Was it policy aligned? Was it calibrated correctly? Was it auditable? Was the failure mode acceptable for this workflow? So good means consistent grading based on subject matter expert input. And that ties exactly back to what Mike was just talking about, right? All of those kind of considerations that influence how a human approaches a task need to be encoded in the rubric so that when we grade an output of a model, all of those steps of a particular task towards a particular outcome, we're doing it in a consistent way and in a way that actually aligns exactly with the way that the human expert would pursue the task. So a simple example, right? Imagine an agent that's designed to support intelligence analysis. It produces a polished looking report, but when you inspect the trace, all of the processes or the steps that the model went through, you discover it only drew from 10% of the available relevant data. If you only score the final answer, you might think the system performed well, but if you evaluate the task, the trace, the outcome, and use a consistent rubric, you'll realize that the process is not trustworthy, and then you can make corrections. That's where the subject matter experts are just essential to the process. The engineers can build the harness and collect the traces, but the standard has to come from people that really understand the workflow and understand the domain in question. They know what evidence should be considered, what policy constraints matter, and where the danger lies in terms of like taking shortcuts and things like that.
I like that you brought up intelligence analysts, Chris. I know we both, in our past lives, we both worked with them. And those that aren't familiar, essentially the way intelligence is created, military intelligence, right, government intelligence, is it's just information until analysis is put on top of it, right? Now, obviously, there's some caveats to that, but generally, that's where most of the intelligence is created. Is it's information that's then analytically looked at by an analyst, and they make an assessment based off that information. And so, one of the things that is really difficult to quantify is the way an analyst approaches a problem. I've worked with some phenomenal analysts. I've worked with some terrible analysts, but really the phenomenal analysts all approached that information differently, whether they were an Iranian intelligence analyst, a Chinese intelligence analyst, a hacktivist intelligence analyst. They approach it from different ways. And the way that they approach it though is based off of that human factor that's difficult to quantify, right? What is their upbringing? Are they a child of immigrants? Do they have a cultural background in that in region of the world? Did they decide that they wanted to study that because they visited as on a vacation as a young child, and they've decided to dedicate their life to it? Is there a particular aspect of that culture that's intriguing to them? And so what do they do on their off time or their free time? And what have they done throughout their life to build up to the way that they approach that problem? Because there's a general way to take that information and perform analysis, but it's entirely subjective and very difficult to quantify.
I couldn't agree more. I mean, I think that's the difficulty from my perspective in building a lot of these agents is understanding the subject matter expertise sufficiently to know what it is you're trying to get into the agentic system. Like it's really hard.
And so, Chris, it sounds like this is also a bit of a, let's say, a data development problem, perhaps.
Hmm. Oh, for sure. Yeah. I mean, I think that's what Snorkel's been doing for the past decade or so. Is we've got more than a decade of work on data-centric AI, how experts encode knowledge from expert people into systems, how data and evaluation assets are built, and how those assets drive model performance. And um, we've learned through research and working with the frontier labs and working with enterprise customers that evaluation is not just the test you run at the end, right? It's the baselining at the beginning, and it's pretty much every step of the way as you're improving the system for high consequence AI systems. Anyways, evaluation is a key part of the development process itself. Yeah, it's not just a testing problem; it's data development problem from start to finish, pretty much. If you have your data, you can make your system. If you don't, you're going to be in a hard spot.
So what does that look like in practice?
Yeah, so the first thing I'd say is don't think of it as a single test. Like I just said, right? This is not a bookend thing. It's a development life cycle. A one-time test will give you a score. A life cycle can give you not just an idea of where you are performing. It doesn't really give you that. It gives you a way to improve. So the way we typically break this down is understand, build, execute, and then diagnose and report. So the first step is to understand the problem deeply. This is what we've just been talking about. It's sitting down with the people who own the workflow and who have been doing this for years and who really understand, maybe they have the deep cultural expertise for an intelligence analyst, or they understand the language and the nuance and the idioms of the target that they're trying to follow. And you have to ask them, what is the AI actually supposed to do? What decision is it supporting? What do you bring to bear when you're making these types of decisions? What tools does it need? What policies does it have to follow in order to stay compliant with the workflow? And what are the completely unacceptable failures? And which failures maybe don't matter quite so much? It sounds basic, but this is honestly where a lot of projects go wrong, is not really taking the time to sit down and understand the problem and the domain you're trying to work through. Team says, we want an AI analyst, or we want an AI claims assistant, but that's not a task definition. That's really just, it's not specific enough to act on. The task definition has to be more specific. Analyze this document, bid against these contract documents, use search and extraction tools, identify missing requirements, blah, blah, blah. We want citations here. That kind of specificity is what makes evaluation possible. The second step is build. So this is where you take the knowledge that you've learned from sitting with the SMEs, the subject matter experts, and you go into create the evaluation assets, build the representative tasks based on what you've learned, the golden data sets, identify the edge cases that need to be included in your evaluation, build the rubrics for grading, the synthetic scenarios, whatever it might be. And remember that, for a lot of these systems now, it's not necessarily just having the question input, it's also having all of the context that the model needs so that you can reproduce your results over time as, say, the data that you have in your live repositories changes. Your evaluation has to have all of the context with the question and the answer and the rubric, right? But the important point is that the subject matter experts are still involved here, right? They have to still define what good looks like. They have to make sure that your golden answers in your data sets are correct. They identify the edge cases, et cetera. So the second step then is to build all of that infrastructure. The third step is to execute it. Now you're going to run your model, your agent, through the evaluation harness. You're going to compare different models or system parameters. You capture the full traces. That's every step of the process that the agent executes. You see which tools they use, what evidence they retrieved, where they deviated from policy, and what outcome was produced. And I would offer that as much as possible, when you're doing that execution, you want to be model agnostic. You don't want to be locked into one model or vendor. This is where you can really get good comparative analysis of the different models that are available to you. You want to be able to swap things out. The fourth step is to diagnose and report, and this is where the real value comes from. You're not going to get a simple score that tells you where the system failed. you're going to get a diagnosis that tells you why. So was the failure caused by missing context? Was it a tool use error? Did it not retrieve all of the necessary evidence to make a good judgment? Was the rubric too vague? Was the task underspecified? Once you know why the failure happened, you can then go back and decide how to fix it. And now we're in that life cycle, right? Sometimes the fix is better instructions. Sometimes it's better retrieval or different retrieval methods. Sometimes it's new training data. Sometimes it's just a different model. And sometimes the right answer is that the system should not automate that step yet. This is why I think leaders should ask for failure taxonomies, not just metrics. If your team tells you the system is 86% accurate, that is not enough. You need to know what's in that 14% error. And then you have to decide whether those failures are tolerable and whether the team has a path to reduce them. So I guess the final point here is really that this has to be a continuous system, right? It's a life cycle. So workflows are going to change. Your systems are going to be dynamic. The policies change. The threats change. If the evaluation doesn't evolve with those changes, the system may still look healthy on yesterday's test set while failing on today's reality. So the practical evaluation system isn't a launch gate. It's a feedback loop, right? Define the workflow, build the benchmark, run the system, diagnose your failures, improve, and then reevaluate. That is how you move from demo to something that you can actually operationalize.
And it's kind of one of the things I want to throw out there is when I first met with Snorkel, and I see there's a question, and I'll get to that on building the trust for sure. But Drew from Snorkel had taken all of the CIA's declassified documents, and essentially what he tried to do was verify that the system that he built could classify them based off of what they were currently classified as. And I know that he said he had a 60%, there was a 60% accuracy. And as I think through the problem, those documents were classified by humans. So they were they interpreted SCGs, and they essentially just took that, Drew took that and used that as the benchmark or the validation that his system worked correctly. And so personally, my conversation with them was that I think that his system was actually more accurate than the humans. But
I remember that. That was actually very funny because, again, Mike, you and I have worked in this system a lot. And so we have an inherent understanding of the fact that humans tend to be very averse to very particular kinds of risk. The last thing I want to do is underclassify a document and then cause a spillage incident or something like that. And so we tend to overclassify, whereas the model doesn't have that fear built in. And so, yeah, it's a very interesting problem.
Yeah, and I would add, like, why this is new from a speed standpoint. You've always had verification and validation as you develop software. What's different is the subject matter expert gave you a requirement to start with. You had some intermediate checkpoints, and then they came back at the end and did it do what they asked it to do. And just the pure time to do that, if anybody's worked on GOT software, that's a long cycle with a lot of players and a lot of subsets of systems, right? So now that is all on what I call steroids, the speed at which you can do that. And if you then tie that to like a military operation where a classification today isn't the same classification tomorrow, and I'll give you a real world example, but this hasn't changed in hundreds of years. We've got the Iranian operation going on, call it what you will, right? When we started the operation, it was a very small group that information was shared with and released to, right? And that's obviously of concerns that, we wanted a surprise. And now the military operation has turned into how do we get oil out of the Straits of Hormuz? And we're sharing information that was probably much different classified before. The beauty of agentic AI is it can stay up with that, but the subject matter experts have to stay up with it as well to change that process. And that used to be a very human intense process. And you can't make, there's always that need to not make mistakes, but humans make mistakes all the time. Anybody that's run a military network, spillage is a real thing. We even, we're going to charge people for it, right? We're going to, we were going to do all the cleanup charges. And then we started charging agencies and holding people responsible. So to me, this is not totally new, right? It's just the speed at which you can do it and the level of technical capability you need to be in this game is much different than it used to be. So we just have to evolve that. But the military operations are also moving a lot faster than they ever did because we have these things called UAVs and swarms, and you now can be a low level player and do that. So you have to get that speed and you have to develop that. And to me, it's still the experts. They're going to drive it, and now they're empowered. So.
Yeah. Before we go into the next slide, there's a question in here from Kurt around, relating to trust. Chris, maybe you'd be able to answer this question, but are you only using NLP-based LLM and generative AI models, or are you using more deterministic models within these agents?
Yeah, sure. I mean, I think it's a good question. It really depends on the task at hand. We are still definitely, if you have the opportunity to use a more explainable model, a more traditional machine learning path or algorithm or something like that, I think absolutely we will still be using those systems. This is where kind of knowing what good looks like out of the gate is so important for the engineers that are going to build your system, right? If I can sufficiently define the task so that it's comes down to either a binary question or a classification task or something like that, I will absolutely evaluate other types of models than LLMs against that task. Obviously, it really depends on the risk calculus that the line of business owner or the leader has, as well as other factors. But the short answer to the question is yes, we definitely still look to employ other non-LLM or generative model types.
And something that Chris just mentioned too about defining the task, and kind of on the first question, Santosh, sorry if I pronounced that incorrectly, but how do you gain trust for the organization, right? How do we get adoption? And really when everybody thinks of Musa, and I work with a ton of customers, and sometimes they think about AI and they just want to throw AI at it and they think it's going to solve all their problems. But the difficult thing is if you can't define that process, if you can't define that task, right, and the processes that go into that task, then you won't be successful. So start small, right? Start small with some of the tasks or the things that are that you can easily define, that you can easily document, and then from there you start to get buy-in from different parts of the organization.
Yeah, I couldn't agree more, Mike. Starting small and starting with explainable is always best if it's possible.
Great. So we're just about to wrap this up, and before the session, I asked each of you to tell me essentially that one question a leader should be asking their technical team right now. And we've covered a lot of ground today, so I'm interested to see if your answers have changed. And John, I'm going to start off with you, and you get what's arguably the hardest question here. But when the system eventually gets something wrong, who owns that failure?
Yeah, I think we all own the failure, right? I mean, it's a team effort. Ultimately, you're going to have the operations folks that own the failure, and then today, anybody that's been a CISO, you get pointed at. Your job is to identify risk, but you learn more from failing than you do from succeeding sometimes. And I think that's, if I'm a risk executive in the government today, I've got to I've got to take some risk to get this done because the enemy is going to use it offensively, right? So we've got to take that into consideration and treat it like a military operation. And I don't care what agency you're in, you've got to think of like, and I think most CISOs today look at it that way, that, you know, we've got weaknesses, and we've got spots, blind spots. And if we don't evolve and accept that we're going to fail and make mistakes and learn from those, I think there has to be a process that does that. I think most organizations today, you know, the military has a chain of command. That's pretty simple. We all understand, you know, the commander's in charge and ultimately they're responsible. I think in some organizations it's a little different on who it is, but definitely the CEO or the president of the company is responsible. And I think AI is bringing that to the light. You can't just turn to the CISO and blame him or her. That's my opinion. It's got to be a team game, and the speed of the interaction is going to lead to, you know, what I call team ball. It's everybody that's got to be on board, and you can't kind of hide the problem, I guess is what I'm saying. I think AI has just brought problems to light, and I think we haven't even seen the wave of offensive capability that we're going to see in this space. So we've got to get quicker at putting out defensive capability. And I think, you know, Snorkel and its approach is, you know, a leader at looking at what that means, because you got to do it. We've got to move faster. We can't be risk adverse. So.
Yeah. I love the framing around the team ownership. And so, Mike, kind of leading directly into your question, right? When the team says this is good enough, what should leaders actually ask, understand what good actually means in that workflow?
So one of the things that, and I keep going back to intelligence, right? There's an intelligence cycle. You could look it up, you could Google it, you can see kind of what that looks like. And there's a very particular step that must occur for that essentially that cycle to be effective, and that's feedback, right? So once we start with defining, and that's the same way that Snorkel approaches it, right? We have to define what we're trying to accomplish. If I can't define it as a SME, then I'm not the SME to define that process, or clearly, obviously, but then I'm not the individual that should be built. We shouldn't be building that system, that agentic system. We can try, but we need to have a SME that can define that process. Once that process has been defined and documented, then we can start to build out the system. But once we get that feedback loop, we have to be flexible enough to say, okay, maybe I was incorrect on thinking that this is a capability I could bring to my organization. Maybe I need to tweak the my expectations of this system. Maybe I need additional information to make sure that I'm successful in this with this agentic system. Does the agentic system have the access to that data? And we talked about it before with with the data labeling and zero trust, but does that system have access to the data it needs to make that decision? And as long as I can document that, and I can give an output and a percentage, not even a percentage, but just a defined outcome, and I can align that to what my expected outcome was based off my defined process, to me that is good enough, right? That is good in a workflow, because the goal is to replicate what a human does, essentially, with any sort of agentic system. So again, back to the intelligence cycle, back to the benchmarking, the way Snorkel does it today, and those two things align because it's effective. That's good enough for me.
Yeah, I love it. And then, Chris, for you, right, at the end of the day, these systems aren't perfect. And when we're talking about trust and these like highly consequential workflows, what do we do with that? Like, what happens when the system is indeed wrong?
Yeah, I think about this a fair amount. I'm going to go back to I don't generally like to compare AI systems to humans, but as a metaphor, it kind of works in this particular case. If you're hiring an intern, we have a whole legal system and you have policies that allow us to make judgments about where we use an intern versus where we use, say, like a 20-year veteran attorney on a particular task. Because when I provide a certain amount of training and I see that they have certain credentials, then I trust people with certain tasks. That doesn't mean they're perfect. They're going to still fail sometimes too. But we understand what that risk means, both legally and from a reputational perspective. And I think that those scaffolds and those kind of shared assumptions don't exist for AI systems yet. We still don't really have a good shared legal grasp on where the reputational and legal risk lies for a system that makes a bad judgment up and down the chain, right? Is it Google's fault if Gemini's in the system? Is it my fault? And so what I think about a lot is talking, and what I spend time doing is talking to a customer about how they perceive that risk and what they're going to do when the system fails. Are they willing and able to assume that risk? Because that'll help us calibrate the evaluation to their expectations so that when the system does have a wrong answer, because it's going to happen, we understand, all of us, we have this shared understanding of what that means for the company or for the commander or for the analyst or for whomever is going to be using the workflow. I think it's a really good question.
Yeah. And so as we approach the end of this event, what I'm hearing across all three of you is that the question isn't, is AI ready anymore? No, it's whether your organization has built out that scaffolding to trust that AI will be able to perform as well or better than your best experts. And then of course to catch it when it's not. And that's really where the hard work comes in. But folks, that wraps up today's session. I can't thank the panelists enough, as well as all of you, for joining us today. If there are additional questions, please feel free to send them through afterwards. We'll try to address them. But thank you all so much for being here, and have a great day.